yx minus 1 half z square plus x plus y whole square equal to 0. So this is the required solution of the given equation. Now see here, so in this solution we have seen another approach to solve the equation. Now let us see another equation. xp plus y cube equal to x minus y. Now we will solve this equation. This is also very simple. As usual, write down auxiliary equations dx upon x, dy upon y equal to dz upon x minus y. Other sentences and other words you can use to write over here as I mentioned in the last two examples. So here it is easy to identify that we can take first two equations. So we can take dx upon x and dy upon y because integration is simple. So the integration gives us log of x and the integration of this is log of y and equal to log of c1. So this will give us x upon y equal to c1 because log x minus log y equal to x upon y. This is the property of log function. Now we will go for the second solution. Here as I told you, first and third equation if we consider it is z dz, but y cannot be removed. You can see directly. And one more important thing, very important thing here, you remember that you don't think that if it consider dz upon x minus y then it is dz. That does not mean that x minus y can be considered as constant. That means you cannot write down dz upon x minus y as x minus y is constant, so x minus y is constant and z, integration of z is z. You cannot do this. You cannot do this. So be careful over here. Because with dx we must have the variable x and with dz we must have the variable z. We can use another equation of approach, but we cannot consider them as directly as constant. Otherwise, if we are considering constant, then no need to see other techniques, other procedures. So here, second solution, for the second solution we cannot take any other pair. It is not possible. So as in the second example which we have seen, can we use this solution over here, x upon y equal to c1, but if we put x upon y equal to c, x equal to c1y, then also it will become harder. Instead of this, is just one idea. We can use first two equations into component and dividend form, dx minus dy. You can also do this. So same as we do in numerator, likewise we can also perform the same operation in numerator. So x minus y, dx minus dy, x minus y, and here we will have dz upon x minus y, and you can see that dx minus dy, x minus y will be cancelled from both sides. So the integration of this one is x minus y minus z equal to c2. So this is the second solution. Here you can also try to put x equal to y, c1y, so y will be common, y and y will be cancelled. So second and third pair you can take. So this is the second solution. So final solution is x upon y, comma x minus y minus z. So you must have observed that it is also possible to obtain the third kind of solution, but we require only two solutions, two different solutions. So we don't go for the third. As here I told you that if we take dy upon y and dz equal to x, x equal to c1y, from this if we put minus y, this implies that dy upon y equal to dz upon y and y will be cancelled from the c1 minus 1. So this has the integration y, and this is 1 upon c1 minus 1, which is the constant. So this has the integration z equal to some other constant, say c. Then you can put the value of c1, you can obtain it. But no need of this. If two solutions are obtained easily, then don't go for the third one, because the third solution will be dependent with second and third solutions. Okay? Now we will go for another equation in which we will make the use of method of multipliers. So y minus z into p plus z minus x into q equal to x minus y. So here you can see the equation from which we can write down as usual auxiliary equations dx upon y minus z equal to dy upon z minus x dz upon x minus y. This we can write after identifying capital P, capital Q and capital R. Okay, so here we cannot use the method of grouping because dx and dy we cannot take. You can identify them easily because integration is not very easy. So here we want to use method of multipliers. So method of multiplier method tells us that we have to identify the multipliers. That means by using, we have to identify three values, say alpha, beta and gamma. We will require to multiply this by alpha, this by beta and this by gamma. So as their summation will become, that means alpha into p plus beta into q plus gamma into r should become 0. So here if we using the multipliers, here I know very well, but you can also identify the multipliers very easily by within half minute. If I use multipliers x, y, z, then you can see that each fraction means all these equal to, because we don't need to write down this once again. So here we should write down them as each fraction. So each fraction equal to x dx plus y dy plus z dz. This is the procedure, just like a method of component row and dividend row. So we will multiply this by x, this by y and this by z and then add them together. So xy minus xz plus yz minus yx plus zx minus zy, and this will become 0. You can verify this. So after if the denominator becomes 0, then we consider the numerator x y dy plus z dz equal to 0. We will consider numerator equal to 0, and integrating this we get x square by 2 plus y square by 2 plus z square by 2 equal to c1. Here 2 I have not written because everywhere there is 2. So 2 into some constant is again one constant. So I will merge 2 in c1. Then another multipliers, using the multipliers 1, 1, because I know very well direct addition will also become 0. Y minus z plus z minus x plus x minus y. That means dx each fraction equal to dx plus dy plus dz divided by 0. So this gives us dx plus dy plus dz equal to 0, and that means integrating we get x plus y plus z equal to c2. So our final solution is f into first one x square plus y square plus z square, comma x plus y plus z equal to 0. This is the second solution which we obtain. Have you understood this? So first method is method of grouping, and second method is method of multiply. This we have used, and in between also we can use the first solution to make simple to obtain the solution of the second solution. So this process is also very simple, and if you will learn some of the questions, some of the examples, then you will observe that really this is very simple and it is very easy to obtain 3 to 4 marks from this one. So friends, this kind of techniques you can utilize to solve Lagrange's first order linear differential equations, and you can solve other examples at your home. You can also solve these examples which you have learned today. I hope you will have obtained your knowledge, enough knowledge and enough process throughout this lecture. If you have not understood anything, then you will write your queries, and queries you can send through WhatsApp group, through which the link is sent to you. Okay, so after collecting all the links, I will arrange one special session to solve all the queries. So I will collect the queries first, then I will we will have a special session. There I will explain each and everything. So don't hesitate to put your queries. You don't get shy to ask me. And however, if you require instant solution, you can call me directly through phone. So I will give you some of the examples. You can try here for your at your home. I will give you simple examples. Practice problems. These problems you must collect, and you will have to solve whenever our regular classes will be held in the college. One example, P plus Q equal to Z. First example, it has the solution f of solution answer, not solution but answer. Answer is capital F of x minus y comma y minus log z equal to 0. Second equation that I will show you is x square p plus y square q equal to z square. Its answer is capital F of 1 upon y minus 1 upon x comma 1 upon z minus 1 upon y equal to 0. Third one is, which I want to give you here, is y minus z upon yz into p plus z minus x upon zx into q equal to x minus y upon xy, and its answer is capital F of xyz comma x plus y plus z equal to 0. So here actually the third equation you can make simple by multiplying on both sides by xyz. If you multiply on both sides by xyz, then the denominators will be removed, and it will become simple for you. So at this time I am giving you 3 equations which you will have to solve for your practice. The other examples, more examples, I will give you during the tutorial time and during the assignment time. And assignment you will have to must prepare one notebook, systematic notebook, by solving all the questions whichever you require to solve. Here one more example, just I would like to by looking the importance of the equation, I would like to show you over here in simple form. Y square cube equal to x plus y into z. See, in short form I will explain to you. Here you can see, first of all, as usual, write down auxiliary equations. Dx upon x square equal to dy upon y square equal to dz upon x plus y plus z. To obtain the first solution, think of the pair. You can easily identify that this pair can be taken. That means dx upon x square equal to dy upon y square, and this can be integrated very easily. This is the integration minus 1 upon x, and this is the integration minus 1 upon y equal to c1. That means the first solution is 1 upon y plus 1 upon x equal to minus 1 upon x equal to c1. This is the first solution. Now for the second solution, we cannot take any other pair because the variables will not allow us to integrate directly. We can also not make the use of first equation. So we will think of method of multipliers to obtain the third solution. So for that we need to use multipliers over here, and so here we will use the multiplier 1 upon x, 1 upon y, 1 upon z. After observing up to half minute or 1 minute, you can identify the multipliers directly by using which you can get denominator 0. So this each fraction equal to 1 upon dx dx plus 1 upon y dy plus 1 upon z dz. By taking this, here you will have 1 upon x means it is x, it will be 1 upon y into y square means y, and 1 upon z means x plus y. So here we will have to use minus 1 upon z, that means minus x minus y. So this will become 0, you can see easily. So therefore we will take 1 upon x dx numerator, 1 upon y dy plus minus 1 upon z dz equal to 0, and integration will give us log of x plus log of y plus minus log of z equal to log of c2. So this is log x plus log y is log of xy, and minus z means xy upon z, and equal to c2. This is the second solution. So here you should write it using the multipliers 1 upon x, 1 upon y, and minus 1 upon z. So here this example illustrates the use of method of grouping and method of multipliers together to obtain the solution. So friends, now it's the enough time for you, and we have seen the solution procedure of Lagrange's equation, linear equation of first order, and you must observe that each and everything is very simple. You can do, you can get practice some of the examples which I have given to you at your home. You can also practice from the book. I will also give you examples in tutorial assignment, and you can send me the queries whichever exist to occur to you. So friends, in the next lecture we will see another method, but be sure to learn whatever I have explained to you, and after completing your collect time, that means after following your timetable, you you spare half an hour to learn this technique. Then I am sure that you will get each and everything. You will solve the question, your solutions.